Their time. And the sound man is setting up as fast as he can. Yes. Can I give him that copy? We can do our introductions before the mic. Oh, that's a good idea. Okay. As you first and foremost, we know our water is in there, comes from there, and needs all of our protection. So Mr. Enright has been very gracious to come meet with us in answer to our letter, and he said he considers this a fact-finding mission.
Pleased to be here, and committed to Bridget. I will be back several times if necessary and work with you on this situation. So thank you all.
I'm here to talk tonight about the possible effects of Hawaii Dairy Farm's proposed dairy on aquatic endangered, threatened, and endemic animals. Not humans at all. We're not in danger whatsoever, but I'm talking about the animals that can't really get away from it. Briefly, we've talked about, people have talked about access points of effluent coming into freshwater systems. The two are overland flow and aerial drift. HDF, as far as overland flow is concerned, HDF proposed putting in 50-foot buffers between their pastures and ditches and streams. Given the amount of precipitation and the clay-like soils around this area in the site, a 50-foot buffer is not going to make it. We're talking at this site, anywhere from 100 to 200-foot buffers might be able to stop overland flow of waters from the pastures into these streams. 50 feet will just not make it. The second source of effluent getting into the streams is through aerial drift. You mentioned that. Everyone that's been out to Mahalapu knows sometimes it can blow like the dickens out there. When that happens, they're going to have to shut down their aerial drift. Don't know how often they look at their wind speeds and how often it's monitored, but eventually aerial drift is going to go into the streams and the ditches in the area. So as far as endangered, threatened, and endemic species that can be affected, they can basically be divided into four groups: aquatic invertebrates, waterfowl, fish, and marine organisms. As far as aquatic invertebrates are concerned, there's 23 species and subspecies of damselflies that are endemic to Hawaii, and 5 species of endemic dragonflies. All of them require oxygen, dissolved oxygen, to breathe. Now, when you think of a dragonfly, you see it flying around. That's just the adult stage. Most of its life is spent in the water as a nymph or a larvae. That's where it spends most of its life. When it's in that environment, it needs dissolved oxygen to breathe. Effluent that's going to enter the freshwater system at Mahalapu will either be from overland flow or aerial drift. It's going to end up in the aquatic systems. And what's going to happen when it decomposes, it's going to use oxygen. It's going to lower the dissolved oxygen in these streams, and it's come down, crashing down to near zero. It'll be fatal to almost all aquatic insects. The only aquatic insects that might survive are, and I'm sorry if I ruin your dinner here tonight, are going to be maggots and the ligochetes, small worms. They can tolerate really low oxygen levels. Next group are the waterfowl. There's 5 different species of waterfowl present in the Mahalapu Valley that are presently listed as endangered. They are the Hawaiian duck, Hawaiian goose, Hawaiian common moorhen, the Hawaiian coot, and the Hawaiian stilt. How will waterfowl be affected? Well, number one, 4 out of the 5 species of waterfowl eat aquatic invertebrates as their main food source. The goose does not, but the other 4 do. If we have lower oxygen levels, invertebrates are killed, your food source for these waterfowl are killed. They're going to have a hard time eating. Second way that waterfowl are going to be hurt by this possible dairy is by the favorable increase in conditions for avian botulism. Avian botulism is brought on by a neurotoxin of the bacterium Clostridium. What happens is ideal conditions for these outbreaks occur when you have low oxygen, high protein available substrates. That's exactly what you're going to have when these effluents enter the ditches and the streams near Mahalapu. Just perfect condition for these bacteriums. Now, this avian botulism is not spread from bird to bird. It's actually spread through the consumption of maggots that hold this bacterium. A lot of these birds will feed on the maggots that are in the substrates. These maggots take up this bacterium in the substrates, and the birds eat it. They are paralyzed and they die. When an infected bird dies, the maggots that are in it, in the carcass, are eaten by other birds. And it's a continuing cycle, and it gets bigger and bigger and bigger until you have a huge outbreak of avian botulism. And it can wipe out huge thousands of birds in, let's say, in an environment like a Mahalapu. These maggot-infested birds can spread the disease to other locations also. If they're infested with these maggots, they can fly easily to another wildlife refuge on the island and infect that wildlife refuge. Next group are the fish. Hawaii has 5 endemic fish species, freshwater fish species. All 5 are anadromous in that they use both freshwater and marine water as far as their life cycle is concerned. They have their larvae in the ocean, but their adults live in freshwater. 4 of 5 species are gobies, and one of them is a flagtail. Conversations with Don Haycock, I do believe you know Don, this week indicate that no fish surveys have been completed by DLNR at Waiopili Stream. As Don indicated to me, actually the proper name for Waiopili should be Waiopili River because it empties directly into the ocean. He considers it to be a river, even though it's very small. I have observed fish in Waiopili. I've gone in about 100 meters from the source where it dumps into the ocean, and I've seen lots of fish there. I do not have a collecting permit in Hawaii to capture these fish and identify them. I wish I did. What needs to be done is there needs to be a detailed collecting survey done at Mahalapu, in the stream, and in the ditches to identify the fish community. Last group are the marine organisms. Many of us have gone out to Mahalapu after heavy rain and seen what the waters look like out in the ocean. They're red, suspended solids. It's incredible how far out the red water goes. What effect will this red water and the added effluent have on 2 of Hawaii's premier marine endangered megafauna? And here I'm talking about the green sea turtle and the monk seal. Elevated nutrients could result in a decline, and this was mentioned before. Nutrients, you get a lot of nitrogen, a lot of ammonia going out into the ocean. It could really shift the algal growth and the seaweed composition that the green sea turtles feed upon. It could even have more exotic species of algae and seaweeds coming in that the green sea turtles don't like. It could spread far and wide. The discharge of waters may affect the fish and eel population. These are the primary food sources for the Hawaiian monk seal. As most of you know, the Hawaiian monk seal is the most endangered sea mammal in North America. Serious questions exist concerning these diseases that could be transferred to these megafauna from consuming contaminated food resources. As Dr. Berg pointed out, Waiopili Stream, or river, has the highest level of bacteria E. coli contamination on Kauai. The entire ecosystem of Mahalapu Valley could be shifted into an irreversible pattern if this dairy goes into place.
I live in Kapa'a. I have a PhD on Hawaiian corals and a master's on Fijian corals. I've been all around the world studying corals, and I'm going to condense my thinking of the last 6 decades into 4 minutes. So who I am is a person who notices that natural history is, and the environment is very important to cultures. And as we lose our natural environment, we're losing culture. Anyone who's driven from San Francisco to Los Angeles can see that. It's just a bunch of malls. I prefer to be swimming every day like you. I love the ocean. And I'm concentrating now on education because I'm terrified. We have so many problems that are environmental problems that are virtually insolvable on our planet, our tiny planet Earth, our water drop. So I am now going from who to what. What is coral? Coral is a living creature. This is just a skeleton. This is a Passalopra. I'll pass it around. Little tiny polyps work together. They're animals living in a thin skin, very fragile, with a plant. So they need clean water for the sunshine to hit the plants for photosynthesis. They can't move. Once they've settled, as a baby larvae, they swim, they settle, and they start to grow. So they are unlike fish or seals that possibly could escape our contamination. I'll pass this around. I love them. They're beautiful. They're the home to all the other creatures on a coral reef. They're very important. Who, what, where? So when I moved to Kauai, I left Japan because of the Fukushima meltdown. And to Kapa'a, I have a small project just offshore. This is the Kapa'a Library and Swimming Pool. I have the only permit in the state to pick up corals of opportunity that are broken but still alive, and I plant them in this area, 100 meters from a waypoint. And I've been fortunate that some of them have survived. Last year's temperatures were so hot, the hottest we've ever had. They went from a high of 82 all the way up to 87. At 83, I started seeing corals bleaching. 84, 85, 86. If they are too hot, their algae leaves and they become susceptible to infection and death. I have several corals that are growing out there, but look at the size of this Passalapra. It's just tiny. So when I came to Mahulipu, I was astonished to see this coral. This is a species of Porides. It might be a Evermanni, it might be a and I've talked to several coral taxonomists. We're not sure what species. This is bigger than my car. This is about halfway down the beach from the stream up to the corner. You can swim out to it. It's as close to the shore as the building over there. It's an easy swim, and it's pristine. It's alive. There are fishes and sea cucumbers growing on it. Anini is dying. Hanalei is dying. I only have 3 species in Kapa'a. This is just beautiful. There's no reason that the wealthy people like Omidyar and Zuckerberg can't do something wonderful for our island. Instead of putting a dairy here, why don't they help the infrastructure, the education, the health of the people of Kauai? So the when is now, and the calendar just happens to hit the point on the head, is we have a lot of work to do right now because things are going downhill very fast. This year is going to be even warmer than last year. We're going to have huge bleaching events. So if you compound warm waters and acidification with runoff from manure from a dairy farm, you're going to definitely impact these corals beyond recovery. So thank you for the opportunity to speak.
The one thing that I did a little bit of research on is the gases, the gas emissions that are that emanate from large dairies, even dairies with 300 cows. This dairy is proposed to start, and I know Ms. Pruder asked the Group 70 International about the numbers and if they had to be pregnant, and they got the word back, yes, they do, because that's a necessary ingredient of lactating and producing the milk. They have to come in pregnant. They either have to come in pregnant or have just recently given birth. But the problem, obviously, in shipping a cow that just recently gave birth is they need to be milked a couple times a day. And that's not something you can do in transit. So they arrive pregnant, and they come in, 699 are going to produce 100,000 pounds of manure per day, 50 tons per day. And that comes from page 42 of the Hawaii Dairy Farms plan. And they describe the manure as more liquid than most, and that gives us concern because of the running over the soils, as we've already heard. In addition, those manure droppings will be not only on the pasture, but it'll be on the raceways and in the milking parlor. In the milking parlor, the plan is to wash it down regularly as the cows get milked. They're going to be milked in mobs. They describe dividing the 699 in 6 mobs of 115. And on page 42 of their plan, they explain that they're going to graze 115 cows on parcels that are 3 to 5 acres, and they're going to use 6 per day and rotate to 6 more the next day. You heard reference to rotational grazing. That's their plan. So an average of 27 total acres will be used per day for all near 700 cows. This creates a concentrated application of waste creates odor, creates gas. Worldwide, cows are described as contributing anywhere between 24% and 40% of the world's greenhouse gases. One study I saw reported it as high as 54%. But they produce more gases, greenhouse gases, than all the carbon fuel burning combined worldwide. Cows beat all engines, all motors in their production of carbon or greenhouse gases. So when these gases are emitted from the cows, they don't just come from the cow itself, but they also come from the manure as it ages and cures. The gases form especially concentrated on the underside of, or the bottom of the effluent pond. They concentrate on the manure solids. And the dairy plans to desludge their manure every 6 to 8 weeks, 5 to 8 weeks in one place that they described. This means that they're going to pull the manure solids off the bottom of the effluent ponds because they can't spray that through the overhead irrigation. The urine and water that's on the top of the effluent pond will siphon over into a second effluent pond, and that's to go in overhead spigot irrigation and be sprayed all over the farm, all over the pastures, everywhere. As I said, everything's to stay on the farm. So you've got manure dropping on the pastures from the cows, giving off gas emissions. The cows give off gas emissions. Then you've got the manure solids that collect and ripen underneath that water coat. And when they get desludged, much literature and quite a few reports describe what's called hydrogen sulfide gases. And I know when I worked with one dairy specialist who is back at the University of Nebraska, one of his assistants told me that when they desludge back there, the townspeople actually leave town, if they can, for at least 2 days because their headaches are so horrible. But the hydrogen sulfide gas not only makes a bad odor that makes people have headaches and nausea, if it mixes with moisture, it forms sulfuric acid. And in upstate New York, we have reports of people losing eyelids, having paralysis of their vocal cords from the sulfuric acid actually burning their vocal cords when they inhale these gases. The burned vocal cords, when they heal, scar, and they don't contract and they don't work like they do. So their voices, and I've seen some of them on film, are very raspy and they can only talk like this. So, you know, there are real health risks to a large concentrated dairy. And the question is it at all safe? And I think the compelling literature indicates not near a large residential community, and especially with children that run and play in Mahalapu. They're at the beach. I can only imagine on a day when they need to desludge. I mean, the beach is public. Public access has to be afforded. They can't close down. They can't keep all the little children out that love that stream and love to loll in the water on the sand, although we've been making parents take them and wash them when we see them. It's not posted. We're trying to get the Department of Health to post it because of the high bacteria levels. But how are we going to protect them from these gases that go through the air and become moistened by our tropical climate? How are we going to keep them from being burned by sulfuric acid?
The essence of Hawaii are basically two things. Isolation, think about that. Being the most isolated land on the planet, we have our effects, and trade winds. The trade winds is what basically provide us our differential, our highly diverse ecosystems, from full-on rainforest. In this island we have a place that gets over 400 inches a year, to deserts within a very short time. And that's because the impact of the island on the prevailing trade winds that come out of the northeast on the average, and they blow significantly for anywhere from 80 to 85% of the year. That's why we have a windward and a leeward side of every island. And that concept has been here since before people came here and started telling them, no, it's north, south, east, and west. You know, when you're living on an island and you don't really think about the compass directions, you either live windward or you leeward or Maka Makai. That's kind of basically things. So if we look at it, this all has been mapped. Hope you can kind of see this. Here's Kauai here with a bunch of stuff around it, and here's a Google image of the island. And I don't know if you can see it or not, but I kind of see a face in the island.
Yeah.
The forehead, a nose, a chin, and the hair streaming back. So it turns out that the trade winds, and this purple line right here is the range, and the arrow there is about the average direction that the trade winds blow. And so if you just move this down a little bit, you see that it blows almost parallel to the Mahalapu coast. Some say that's where Kauai takes her breath, because that's where the strongest winds are, not only on our island, but probably the whole state. It's probably one of the windiest coastlines in the whole state. So that's right along here, and Mahalapu's right in the middle of that. So we flew along there today and were able to feel some of those kind of winds. In addition to the winds that we know in recent times when people have measured them, I've actually looked at the fossil winds. I bet you never heard of that before. How do you measure a fossil wind? Well, the wind that blows along that coast will pick up the sand off the isolated beaches that are along there. Mahalapu Beach, Hauula Beach, there's a couple unnamed beaches there. Wherever there's sand on the shoreline, the winds blowing along the coast will pick up that sand and transport it downwind and build sand dunes. You know, and you probably run down a sand dune or two in your lifetime, or you run up the back and you run down the front. Well, that front of that dune will migrate. It will move downwind. So if you find ancient sand dunes, and we have piles of them down there at Mahalapu, the whole coast is all limestone. It's all beach that's been blown up into dunes and then cemented. Now that's a whole other geological process, but there are other things in there called the lithified sand dunes or cemented sand dunes of Mahalapu. They're the best, the largest, and the most extensive in the whole state. And so they are a result of wind. And I've gone in and measured a few hundred of those surfaces that when you measure them, it tells you the direction the wind was blowing when that surface was created. And it turns out that over the last 400,000 years, 400,000, that's right, the winds have never changed. The arrows of the winds point straight down the coast. And they start up near Kipukai area. There are some there, and around that point, and they go down the coast. There are no on-land winds. They're all along the coast. And some coasts there are, sea breezes where the wind will blow landward during the evening and seaward during the day. Not here. This is totally dominated by the trade winds, and they blow right down the coast, and they are about as strong as you can imagine. So the point is, and I've got all this stuff. You can look at my book. It's all in there. So you can think about that in terms of where all that disseminated material in the air, the particulate matter and the gases and the emissions are going to end up. It's only about a mile from that area to Makawina Point, the southernmost point on the island, which is right into Poipu, right next to Shipwrecks Beach, right next to the Hyatt Regency Hotel. So, we know they're happening. So that stuff, anything that's produced out there, it's going to end up in the atmosphere. It's going to end up down the coast. And a mile, I don't know if it's all going to dissipate within a mile. I don't know. I mean, that hasn't really been determined. But I suggest probably not. That's not very far for that to happen. Another indication, if you like, anywhere along that coast, if you find that the sand dunes that are there now, there are modern sand dunes as well as all the ancient ones. They're just piled up one after another. The ironwoods, the Australian pine, loves that sand. And so that's how you can almost map the dunes in there, by just mapping the vegetation. And anytime you find them, they don't stand up straight. They're all growing like this. They're all leaning over. So if that isn't a pretty good wind indicator, you don't need to go and measure the winds every day for 10 years to figure out that it's a very windy place. And anything produced upwind is going to end up in a very short distance right downwind from there.
Really misrepresented to the community, and I'll just tell you this in person, Mr. Enright, as I wrote about it. When we first came into this room, February 27th, 2014, they stood before us, and people knew they were out there preparing They saw the dirt, they saw the grasses, they saw trees being uprooted, and they said, how is it if you don't have your permit from the State Department of Health, how can you do this? And they said, because we have an NRCS permit approved. And that was a big problem because we believed them. And so we talked among ourselves and we said, maybe it's not so bad. Let's go to the NRCS and find out what they had to do to get an NRCS permit. And we were told by the NRCS office chief that they don't issue permits and they don't approve plans. They help farmers develop plans, but there isn't a plan approval process.
We're there. And so, I've always valued that coastline. And I've lived here in the county. I've worked for the sugar companies in the past. I've spent time here. So I knew what that coastline looked like, and I knew what the valley looked like, and I've looked at it on enough maps, enough planning instruments for agriculture. Growing up with Carl, when we got up and with Chuck, and they're sharing their perspective, and then we go up and look at it. You look at it in a different way. And as an Aggie, I'm usually looking for agricultural development too. But being up there looking at it as an environmentalist, which is what I was asked to do, I could see the points that they were making. So again, what's being asked of me by the governor, by your governor and my governor, is scientific inquiry. And I'll do just that because that's my charge.